The darkness between stars is not empty. For millions of years, something has been moving through the void. A wanderer without a sun, a messenger without a voice, a shape that defies every law we thought governed the cosmos. On October 19, 2017, humanity glimpsed the impossible when Oumuamua, the first confirmed visitor from interstellar space, pierced through our solar system like a needle through fabric. Scientists watched it tumble past at 196,000 miles per hour, its elongated form rotating through the darkness, reflecting sunlight in pulses that suggested something no asteroid or comet in our cosmic neighborhood had ever resembled. But Oumuamua was merely the herald. Now, telescopes have detected another arrival. This one is different. This one is incomprehensibly larger. Astronomers who first processed the data sat in stunned silence, rechecking calculations that seemed to violate probability itself. The numbers suggested an object so massive, so structurally impossible, that its very existence threatens to rewrite our understanding of planetary formation, stellar death, and the hidden architecture of the galaxy. What travels between stars? What force could launch something of this scale into the endless night? And why, after wandering through 400 billion suns, has it chosen this moment to enter our small corner of the universe? Chapter 2. The Discovery Phase. Establish the detection timeline at the Pan-STARRS 1 telescope in Maui, Hawaii, the same facility that discovered Oumuamua. Detail the night survey astronomer first flagged the object as an anomaly in the automated detection system, appearing as a faint streak moving against the background stars with unusual speed and trajectory. Explain how within 72 hours, multiple observatories confirmed hyperbolic orbit characteristics, mathematical proof that this object originated outside our solar system. Introduce the team of scientists at the Minor Planet Center who calculated its orbital eccentricity far exceeding 1.0, meaning it possessed enough velocity to escape the sun's gravitational influence entirely. Describe the initial confusion. Preliminary brightness fluctuations suggested extreme tumbling, but the light curve patterns indicated dimensions that seemed physically impossible for a natural object. Detail how ESO's very large telescope in Chile, the Keck Observatory, and NASA's Hubble Space Telescope were immediately redirected to observe before the object moved too far. Explain the urgency. Interstellar objects move so rapidly through the inner solar system that the observational window lasts only weeks before they vanish forever into deep space. Introduce Dr. Karen Meach and other planetary scientists who raced to gather spectroscopic data, measure albedo, track rotation periods, and determine composition before the visitor disappeared. Established that what they began to see in those first observations defied every model of interstellar object populations astronomers had constructed. Chapter 3. The Scientific Shock. Present the devastating revelation. Initial size estimates based on brightness and albedo calculations suggested this object measured not hundreds of meters, like Oumuamua, but several kilometers across, potentially reaching 10 to 15 kilometers in its longest dimension. Explain why this is paradigm-shattering. Objects of this scale require entirely different formation mechanisms. Comets and asteroids typically measure hundreds of meters to perhaps 2 kilometers. Something this massive should not exist as a rogue wanderer. Detail the shape problem. Light curve analysis revealed brightness variations indicating an aspect ratio even more extreme than Oumuamua's suspected 10-1 elongation. The tumbling pattern suggested this object might be 20 times longer than wide, a proportion never observed in any natural solar system body. Introduce the velocity paradox. Despite its enormous mass, the object traveled through space at speeds suggesting it had been accelerated by more than simple gravitational slingshot from its parent system. Calculate the energy required to launch something this massive into interstellar space. Explain the composition mystery. Spectroscopic observations showed a surface that reflected light in ways inconsistent with stone, ice, or known metallic compositions. The reddish coloration suggested irradiation by cosmic rays over vast timescales, but the underlying material remained unidentifiable. Present the scientific community's confusion. Established models of planetary system formation couldn't explain how an object this size becomes an interstellar wanderer, and the physics of its trajectory suggested forces that shouldn't exist. Chapter 4. Deeper Investigation. Chronicle the intensive observation campaign mounted by astronomers worldwide. Detailed data from the Hubble Space Telescope's precise measurements of the object's trajectory and the detection of non-gravitational acceleration, a subtle push that couldn't be explained by the sun's gravity alone. This echoed Oumuamua's mysterious acceleration, but on a larger, more pronounced scale. Explain how NASA's Spitzer Space Telescope attempted infrared observations to determine the object's temperature and thermal properties, revealing anomalies in heat retention that suggested either an extremely unusual composition or an internal structure that defied normal solid body physics. Present findings from ground-based radio telescopes, including the Green Bank Telescope, which swept the object for electromagnetic emissions and found none, ruling out certain artificial origin theories but deepening the natural formation mystery. Detail how spectral analysis by multiple observatories revealed no outgassing, no cometary tail, no dust cloud, yet the non-gravitational acceleration persisted. Introduce measurements of the object's rotation. It tumbled chaotically, spinning on multiple axes simultaneously, in a way that suggested either a recent violent event or an inherently unstable structure. Explain the density calculations. Given the object's brightness and estimated volume, its density appeared far lower than rock or iron, possibly lower even than water ice. This suggested either a porous interior filled with voids, an exotic composition unknown in our solar system, or a structure that challenged conventional understanding of how cosmic bodies maintain integrity. Present the growing realization that this was not merely a larger version of Oumuamua, but something categorically different. Chapter 5. Escalation. Mystery deepens. Reveal the terrifying acceleration data. As the object passed perihelion and began its outward journey, astronomers detected that its non-gravitational acceleration was increasing, not diminishing, as would be expected from cometary outgassing. Present the structural impossibility. For an object this elongated and massive to survive intact across interstellar distances, it would require tensile strength exceeding any natural material known to physics. Calculate the tidal forces it must have endured during its closest approach to any star. Explain that rock, ice, and even iron would have fragmented under such stress. Introduce the trajectory refinement. As more observational data accumulated, astronomers traced its path backward through the galaxy. The vector pointed toward a region of space containing no known stellar systems within 300 light-years. It had traveled from apparent emptiness. Detail the time paradox. Cosmic ray irradiation patterns suggested the object had been wandering interstellar space for potentially hundreds of millions of years, yet its structural integrity and stable trajectory seemed impossible to maintain over such timescales without gravitational binding to a star. Present speculation that began emerging in scientific papers. Could this object be a fragment of something far larger, a shard from a planetary collision so violent it exceeded escape velocity? Or perhaps material ejected during a supernova event? Explain why each hypothesis created new problems. Supernovae produce specific ejector signatures this object lacked, and no planetary collision model could generate the required velocity and preserve such extreme elongation. Reveal the most disturbing observation. The object's brightness fluctuations contained subtle periodicities that some researchers suggested might indicate internal structure, layering or compartmentalization that natural processes don't produce. Chapter 6. Theories and Speculations. Present the leading scientific hypotheses in depth. Theory 1. Tidal disruption fragment. Explain how Chinese researchers propose that objects like Oumuamua could form when a planetary body passes too close to a star and is torn apart by tidal forces, with elongated fragments ejected into interstellar space. Detail why this might explain the extreme shape, but struggles with the size and acceleration data. Theory 2. Nitrogen ice body from a Pluto-like world. Describe ASU astrophysicists Stephen Desch and Alan Jackson's model, suggesting these objects are frozen nitrogen from exoplanetary surfaces, explaining low density and unusual outgassing. Explain the hypothesis that cosmic ray erosion could have ablated the object down from a much larger body during its interstellar journey, creating the extreme aspect ratio. Detail why this model struggles with the massive scale of the new object. Theory 3. Fragment of a failed star. Introduce speculation that the object might be exotic matter from a brown dwarf or substellar object that was disrupted by a close stellar encounter, potentially explaining unusual composition and density. Theory 4. Stellar death ejector. Explore the hypothesis that dying stars in their final pulses eject planetary material at extreme velocities, with this object representing a fragment from a stellar system's death throes. Present Avi Loeb's controversial extraterrestrial technology hypothesis, explaining the scientific community's pushback, but acknowledging the observational features that resist natural explanation. Detail why the new object scale makes artificial origin less plausible, but also more terrifying if true. Introduce quantum vacuum hypothesis. Speculative physics suggesting false vacuum decay. Events might produce exotic matter states capable of surviving interstellar transit. Explain Einstein's relativity constraints on material strength and why this object seems to violate structural limits general relativity imposes on elongated rotating bodies. Chapter 7. Scientific Tools and Ongoing Testing. Detail the global scientific response mobilized to study the object before it vanishes. Explain how the Vera C. Rubin Observatory in Chile, with its unprecedented wide-field survey capability, is being used to search for additional interstellar objects, potentially revealing whether this arrival represents part of a population or a singular anomaly. Describe the James Webb Space Telescope's planned infrared observations designed to penetrate any dust shroud and analyze the object's surface composition with unprecedented spectral resolution. Detail how NASA's Lucy mission currently en route to Jupiter's Trojan asteroids, captured images of the object from 240 million miles away, providing crucial parallax measurements that refined its three-dimensional structure. Explain the role of the Event Horizon Telescope network in attempting to resolve surface features at the absolute limit of observational resolution. Present the theoretical work being conducted using supercomputer simulations at institutions worldwide, modeling possible formation scenarios and testing whether known physics can produce such an object. Detail radio astronomy campaigns by SETI-affiliated observatories monitoring for any anomalous signals, not because scientists expect to find them, but because the observational protocol demands ruling out all possibilities. Explain how particle physics laboratories are investigating whether exotic matter states could exist with the required properties, low density, high tensile strength, and unusual thermal behavior. Describe plans for future space missions, proposals for high-speed interceptor spacecraft that could launch within decades to chase down the object before it passes beyond the heliopause, equipped with instruments to determine composition, internal structure, and electromagnetic properties. Present the sobering calculation. Even with breakthrough propulsion technology, catching an interstellar object requires launch windows measured in months and trajectories that commit spacecraft to one-way journeys lasting decades. Chapter 8. Philosophical Reflection. Emotional Close. Contemplate the profound implications of interstellar wanderers of this scale passing through our solar system. Reflect on the statistical revelation. If an object this massive can arrive from the void, how many others travel the darkness between stars? Astronomers estimate 10,000 interstellar objects orbit within Neptune's path at any moment, most too faint to detect. The galaxy might contain trillions of rogue planets, orphaned moons, and stellar debris, an invisible population outnumbering the stars themselves. Explore the temporal mystery. This object has likely traveled for 300 million years or more, launched from its parent system when dinosaurs first emerged on Earth. It has witnessed the galaxy from perspectives no human mind can grasp, pass through nebulae and dust clouds, perhaps skimmed close to other stars, carrying with it the chemical signature and physical record of a solar system humanity will never observe. Contemplate the formation question. Planetary scientists believed they understood how solar systems eject material, through gravitational interactions during formation, through stellar death events, through catastrophic collisions. This object suggests mechanisms we haven't imagined, energies we haven't calculated, or formation environments we haven't modeled. Consider the anthropocentric realization. For all recorded history, humanity believed the solar system was an isolated, stable system. The discovery that massive interstellar objects regularly pierce through our cosmic neighborhood reveals that the sun's gravitational domain is not a sanctuary, but a crossroads, constantly penetrated by material from distant, alien worlds. Reflect on the unanswered questions. Where did it form? What violent event launched it into the night? Has it passed other civilizations, other worlds where beings looked up and wondered at the same mystery? Will our descendants ever develop the technology to catch such objects, to study them directly, to read the geological and chemical stories written in their ancient surfaces? Present the ultimate philosophical weight. These interstellar visitors are messages written in the language of physics, carrying information about stellar death, planetary destruction, and the hidden violence that shapes the galaxy. We have decoded only fragments of that message. The visitor moves outward now, accelerating past Mars, past Jupiter, eventually beyond the heliopause into the interstellar medium. In a few years, it will be too distant to observe. In a few decades, it will be halfway to the nearest star. In 1,000,000 years, it might enter another solar system, where other beings might look up at the night sky and ask the same questions we do. The cosmos is not silent. It speaks in the grammar of wanderers, in the syntax of objects that shouldn't exist. We are only beginning to learn how to listen.